Hello everyone, welcome to this presentation on confidence interval for proportion. So in this short presentation, we are going to construct the confidence interval for the population proportion, and we are going to estimate the sample size required for that. Okay, in order to find the confidence interval, what we need is we need a point estimator in the middle, and in this case our point estimator will be the population proportion. And we want to construct an interval, and we want to predict that the population proportion lies in this interval with certain confidence level. So for a sample of size n, if the proportion is p hat, then the confidence interval for the estimation of population proportion p with certain confidence level is given by this formula, p hat plus or minus margin of error, which is same as the population proportion p lies between p hat minus margin of error and p hat plus margin of error. And margin of error is calculated using this formula here. Margin of error is equal to z sub alpha over 2 times the square root of p hat multiplied to 1 minus p hat divided by n. Or you can substitute z alpha over 2 by z critical. So your formula will be margin of error is equal to z sub c times the square root of the quantity p hat times 1 minus p hat over n. Okay, this is the formula. This is the formula for constructing the confidence interval. It involves the margin of error, and we use the second formula to find the margin of error. Now the second thing is, if we want to construct a confidence interval with certain confidence level, what should be the sample size? So if you want to estimate the sample size, the minimum sample size needed for estimation of population proportion is given by this formula. And by calculating this one using the formula, or by calculating the value of n or sample size using this formula, if we get a decimal value, you always need to round it up to a whole number. So that is the introduction to confidence interval for proportion. Let's take an example. Okay, here is the example. Out of 200 people sampled, 162 had kids. Based on this, construct a 99% confidence interval for true population proportion of people with kids. So what we are going to do first is we are going to write down this information. Our sample size is n equal to 200. The proportion of people who had kids is 162 out of 200, which is same as 0.81. And we are looking at 99% confidence level. So for 99% confidence level, we can find z sub c using calculator. So what we can do is grab your TI-84 calculator, then go to second, then vars. Give me a second here. Second, vars number 3. So area is 0.99 because that is our confidence level. Mean 0, standard deviation 1 for standard normal distribution. Obviously this area will be in the middle, so center, and then paste this and hit enter and write the positive value. Because you are getting two values here, that is the value on the left end of the area and value on the right end of the area. You can just write the positive value. You can even round this to whatever number of decimal you want. For example, if I want to round it to 4 decimal places, I can select 4 here. so that this calculator will round everything up to 4 decimal places. Let me recopy that and enter so that I get up to 4 decimal places. Okay, it is 2.5758. 2.5758. Okay. Now, once you know the z sub c or z critical, now we can find the margin of error. Margin of error is given by the formula z sub c square root of p hat multiplied to 1 minus p hat divided by n, which is equal to z sub c 2.5758 multiplied to the square root of p hat is 0.81 times 1 minus 0.81, which is 0.19, divided by sample size, which is 200. And this is equal to, let's type this in our calculator. Okay, so we have 2.5758 multiplied to the square root of 0.81 times 0.19 divided by 200 and hit enter. Oh, I did something wrong. Let's check it again. Okay, you can see I entered 2 decimals there. That's why 2.5758 multiplied to the square root of 0.81 times 0.19 divided by 200. That is equal to 0.0715. Okay, 0.0715. Point, you can verify one more time. 2.5758 times that. Okay, I'm just checking here. 2.5758 multiplied to square root of 0.81 times 0.19. 0.81 times 0.19 divided by 200. Yeah, that is 0.0715. 0.0715. So the margin of error will be 0.0715. Now we can write our confidence interval. Now what we know is our confidence interval will be p hat minus the margin of error is less than p, which is less than p hat plus the margin of error. Okay, let's find this in our calculator. P hat is 0.81. 0.81 minus margin of error, which is got here, which is 0.0715. I'm typing something wrong. Again, 2 decimal places there. Let me retype it. It's quite difficult to type in computer. P hat 0.81 times 0.19 0.81 times 0.91. Am I doing it right? No, something is not working here. Hold on. Okay, p hat is 0.81. 0.81. Then you have a minus, and the margin of error 0.0715. Okay, that is the lower boundary for the interval. The upper boundary will be, we have plus in the middle. This sign must be plus. Then that's what we get. So it's from 0.7385, 0.7385 up to the upper bound is 0.8815, 0.8815. So that is the confidence interval for the population proportion. That means the probability that the true population proportion lies between 0.7385 and 8815 is 0.99. Or we can say that with 99% confidence, we can say that the true population proportion lies between 0.7385 and 0.8815. So that is the end of this example. I just want to check one thing, the margin of error that we have calculated here. Let's see whether I type everything correct and got that value right. Just to make sure, I think we did it right, but just to verify, I'm typing this one, 2.57, 2.58 multiplied to the square root of, inside the square root we have 0.81, 0.81 multiplied to 0.19, 0.19, that is divided by 200. Everything is inside the square root. That's good. Again, I am not typing something right. Let's go back and check it. There's two multiplication sign again. 2.5758 multiplied to the square root of 0.81 times 0.19 divided by 200 divided by 200, 0.0715. Okay, we did it right. So that is the end of this first example. Let's work on a few more examples, because if you go back and look at the theory that we have studied, we learn how to find the sample size to estimate the population proportion. So let's take an example based on that. So here is the example. Let's see what is going on in this example. A political candidate has asked you to conduct a poll to determine what percent of people support her. If the candidate only want 5% margin of error at 90% confidence level, what size of sample is needed? So here we are talking about the politician being supported. So for the politician to be supported, someone who is in favor of her must be more than 50%. So here we can say that for the proportion of people to support her, P hat must be at least 51%. So let me write that first. For the proportion of people to support her, P hat must be at least 51%. Give me a second. P hat must be at least 51%. That is what it is. The margin of error she is looking for is 5%, which is same as 0.05. Okay, and the confidence level is 90%, and you know that at 90% confidence level, okay, 90% confidence level, your Z sub C or Z critical will be 1.6449. This is how you can find this. If you go to your calculator, you'll do second, then vars. See, something is not working today. Second vars Then number 3, it's 90%, so this area must be 0.9, mean 0, standard deviation 1, that's in the center. Then paste, you'll see it is 1.6449. Okay, so once we have all this, we can find the sample size for the uh, required proportion and the confidence level. So the sample size required for this is equal to n is equal to p hat times 1 minus p hat multiplied to z sub c divided by the margin of error squared. It is this formula here, this one. Z sub alpha over 2 is same as z sub c. That's why I use z sub c here. Okay, let's plug in the values. This implies n equal to p hat is 0.51, because if c get at least 51%, then we say that the population is in support of her. Multiplied to 1 minus p hat, 1 minus 0.51 is 0.49. Multiplied to z sub c 1.6449 divided by margin of error is 5% or 0.05. Square all this. This implies n is approximately, because we round it to a bigger whole number, let's see, 0.51 multiplied to 0.49 multiplied to, inside the parenthesis we have 1.6449 divided by 0.05, and we are squaring this, which is equal to 270.4614, but we are rounding up, so it is 271. So this is 271. So in order to conduct a survey to see whether the politician is being supported or not, with 5% margin of error, we need a sample size of 271 people. So we have to ask at least 271 people. Okay, that is example 2. So let's take one more example on the proportion here. And then here is the example. Okay, let me erase this one first. There we go. Okay, express the confidence interval 19.2% to 33.8% in the form of p hat plus or minus margin of error. So meaning of that is your lower end is 19.2 for the interval. Okay, lower boundary. Upper boundary is 33.8, and you know that the lower boundary is p hat minus margin of error. So here p hat minus margin of error is equal to 19.2. Suppose that's my first equation. And then p hat plus margin of error will give you the upper bound for the interval, which is 33.8. Equation 2. We need to solve this system of equation to find p hat and margin of error first. So if I add these two equations, let's see what I get. Adding equation 1 and 2. I am solving by elimination method. So if I add p hat plus p hat over here, p hat plus p hat is 2p hat. And then margin of error, negative and positive cancels, equal to 19.2 plus 33.8, which is 53. Okay, that is 53. So if I divide this on both sides by 2, what we get is p hat is equal to 26.5%. Okay. Similarly, we need to find the margin of error. So for that, I'm going to subtract equation 1 from equation 2. So subtracting equation 1 from 2. So if we subtract, what we get is p hat minus p hat, that is equal to 0. And margin of error minus a negative margin of error is 2 margin of error, equal to 33.8 minus 19.2 is 14.6. Now if I divide on both sides by 2, then we get our margin of error. Margin of error is 14.6 divided by 2 is 7.3. So this value is 7.3. Hence what we are looking for is, we want to write this interval in this form. We want to write it as p hat plus or minus margin of error, which is equal to your p hat, which we got here, is 26.5%. Okay, then plus or minus the margin of error, which is 7.3%. So plus or minus 7.3. This is all in percentage. So we change the interval given in this form to that form. Okay, so that is the third and the last example from this video. Thank you so much for watching. I hope you find this helpful.